Hi, my name is Ryan Langwish, and this is Ludo Lodge, a channel all about making resources for game designers. And today I'm going to be continuing my series of tutorials in Tabletop Simulator, specifically scripting in Tabletop Simulator, talking about how to implement a button for auto drafting. So basically, a button that you click, and it's going to pass the cards from my hand to the person on my left, and all the way around the table for all the players that are currently seated. This is a pretty common feature in a lot of modern board games, whether it's Seven Wonders or Sushi Go or Bunny Kingdom, or there's a lot of different examples of using card drafting. And it might be something that you want to put into one of your mods. So I'm going to go over that today. If this is your first time on this channel, or you're new to scripting, I'd recommend maybe starting with one of my earlier videos. I'll link my intro to scripting up above, or maybe check out the full playlist I have on Tabletop Simulator tutorials, which is linked down in the description below. I'm probably going to start brushing over some of the very basic things a little more than I did in the earlier videos, just to kind of keep myself from bogging down the videos too long with a lot of the same concepts. But otherwise, let's just jump into it. So here I have my deck of cards, and I have my trusty checker here that I typically use to attach the actual buttons to. And if you're familiar with Tabletop Simulator, you know that if you go into Zone here and go to Hands, it's pre-configured that there's these hand zones around the table, and this is where different players can pull in cards and hold them in their hand. And because I'm the white player, I can now see this in my hand. And so what we want is when we click the button that we're going to add here, we want all the cards in white's hand to go to the red player, all the cards in red hand to go to the orange player, and all the way around the table. And actually, a little more intelligently, we want it to only include players who are currently in the game, that are currently seated. We don't want it drafting to colors that are unchosen in your particular game. So as usual, we're going to start out by adding our button here, and I'm actually going to just speed through that since I've talked about that a little bit already in previous videos. Alright, at this point we have our button, and if I save and play here, we can see that that currently doesn't do anything. And we have it tied to this pass cards function, which is what we're ultimately going to want to put in our Lua script here. So let me add that. It's going to be function pass cards, and this is ultimately what's going to hold all our logic for the drafting. Now we're actually going to use a new concept here that I haven't used in any of my previous tutorials, which is that of a Lua coroutine. So we've used functions before, how you can define functions as just a block of code and then call that in other places to have it run. The difference with a coroutine is it's a function that allows you to kind of pause within the execution of the script, as opposed to having the entire script executed in one frame of game time. So normally if this function is called, it's going to execute all the code, and only once that's all done is it going to continue to the next frame in our 30 frames per second, 60 frames per second, whatever Tabletop Simulator is running in. And what a coroutine allows us to do is we can be running code, but then we can call this yield statement to say, hey, pause here and don't pick up again until the next frame or after a certain amount of seconds or something. The reason that's going to come into play here, and that's going to be a little more evident later, is because of the simultaneous nature of drafting, that if I have it all do it at once, we actually run into some weird issues with one of the players ending up with 2 cards and with none cards, because you kind of run into these weird logical collisions of all that happening at once, and it fixes it by just telling it to kind of pause between passes. All of that is to say that we're going to set this up a little differently in that this function is what's tied to when our button is pressed, but we're ultimately going to have another function that's going to be our coroutine that's going to have most of the logic. So I'm just going to call that pass cards coroutine. And the way that you're going to call a coroutine is by calling the start Lua coroutine method, if I can spell. And we're going to call that on self, meaning this script. I could put like global if the coroutine happened to be in my global script. And then just as a string, I'm going to pass the name of it, which is pass cards coroutine. So that's just going to basically call this function. So that's a good start for our structure, but there's an additional check I want to put in place here to basically protect against like double clicks, or if someone clicks the button quickly, you know, if we're in the middle of it executing a draft, we don't want to mess things up by like it executing again too quickly. So we're actually going to introduce this flag called pass in progress. And when I say flag, I just mean I'm going to use a Boolean variable that's either true or false, so I can just flip it one way or the other. And it's going to start at false. We don't currently have a pass in progress. But when we're here and we click that button, we're going to check if not pass in progress. So we're not currently passing cards. Then we want to start this coroutine. And we want to actually set pass in progress to be true, because we are beginning a pass beginning a pass that's now going to be in progress. Now this flag here, we're going to then want to set back to false when we're done passing the card. So that way it'll be available to be clicked again. So that'll end up really being at the end of this function, which we could put in here just so that we don't forget. We're going to want to set pass in progress back to false. Additionally, a coroutine is required in Lua to just return 1 at the end. There's probably other values for that, but as far as this case, we're going to return 1 as part of the coroutine, which is just a Lua thing. So we've got our basic structure here, and actually we could test it. It's always smart to test things, which is easy to do with something like a print statement. We're going to print hello. I'm going to save and play. And we should expect that if I click this, I should see hello down in our console, which we do. And we should also expect that if I click it quickly, I shouldn't see it for every single... Well, actually, that's not true, is it? I'll still see it for every single one. And the reason is because there's nothing in this that's taking up any time. So, you know, it's going here, it's printing this, and then it's immediately setting this back to false. So it's still every single time. But because this coroutine is going to end up having those yield statements, those pauses that are going to wait, you know, between frames a little bit, this function is going to end up taking longer than a single frame. And so it's possible that you could click more quickly before this gets set again. But that appeared to be working. So let's get rid of this. And let's think about what we actually want to have happen here. So I'm actually going to save this. If we go back and look at our hands, we care about the order of these colors, these players around the table, right? We want white to pass to red, red to pass to orange. That order matters. So we need to kind of establish that in our script. And so what I'm going to do is up at the top here, I'm going to create a variable called all players, and I just use this all caps styling to indicate what I intend to be a constant, something that's not gonna, this variable is never gonna change. And I'm just gonna do a list, or in Lua it's just a table, of the player colors specifically in the order that they're sitting around the table. So that's red, orange, then we've got yellow. I might bump this down here. And what this will allow us to do is we're going to have to do a couple things. We're going to have to check which players are currently in the game, because we don't want to pass to players that aren't in the game. And we can kind of compare that with this list to determine exactly who should be passing to who, or whom. Grammar. So once we have that, the first thing we kind of want to do in here is we want to establish what is our list of actual players involved in the draft. This is all the, you know, if we're in an 8-player game, it might be all of these, but that's probably not the case. And so what I'm going to do is I'm going to make a variable here called sorted seeded players, and just make it an empty table. And it's going to be a combination of two things. It's going to be sorted, as in using the same order as our dictionary or our table up here, but it's going to be seeded players, meaning only players that are currently seeded in the game, which fortunately Tabletop Simulator gives us a nice method for. And so we're going to have a loop here. We're going to basically go over each color in are all players. So as a reminder, I pairs is going to basically, for each time through the loop, give us an index and then the actual element in the table. I'm going to mix up table and dictionary a bunch of times here. In the table, and so color is going to be, white, red, orange, yellow. Here, we don't care about the index. It would be 1, 2, 3, 4. So by convention, you just put an underscore if you're not going to be using it. Each time through this loop, we want to ask the question, is this player seated? Is white seated? Is red seated? Are they in the game? So we're going to say if player color, so this is just something that the player class in the API has the ability to, you can get the player by color, and then that player object has a property called seated. And that'll be true or false depending on whether they are currently in the game. So if that player is seated, then we would like to put it into our sorted seated players. So we're only going to put things in there that we find are seated. And so we do that using the table insert method. And we are going to insert the color, right? So if we found that white was seated, we want to put white in here. Now, this is how we want the behavior to work. Like at the end of this loop, this table should have only the colors in it that are currently seated. However, it's going to be a little tricky to test that because I am only one person and I can't take on more than one color in my testing here. So as a result, I'm only ever going to get white in here, which, as you can imagine, is going to make it difficult to test drafting functionality. So what I'm going to do here is I'm actually going to introduce another variable up here. And I'm going to call it, let's actually throw it at the top here. I'm going to call it debug, which is just going to be true or false. And I'm going to set it to true, meaning we're currently in kind of the debug mode of we're trying to get the script to work. And I want it so that if debug is true, we just consider all of the players to be seated so that way we can figure out the logic. But eventually, if it was actually being run in my game, I would want to set it to false and have it actually use the people that are seated. So the way we're going to work that in here is we're actually going to say if debug or player color seated. So this if conditional here is going to evaluate to either true or false. And because it's an or statement, only one of these needs to be true for it to go into this conditional. So if debug is true, it's actually not even going to check player color seated. It's just going to short circuit in here and it's going to insert them in. So I'm going to get all of the colors. However, when debug is equal to false, it's going to say if false or player color, meaning this would need to be true to get in. So that just allows us to switch back and forth whether we're working on the script or not. So at this point, we should have a table of just our seated players, and it should be in the order of this ordering defined up here, because we looped through the order of all players, so we encountered those colors in that order. So now for each one of those, we want to have them pass their hand to the person on their left. So again, we're going to have a loop, but this time we're going to loop over our sorted seated players. And this time we actually do care about the index, which will become apparent here in a moment. So this is going to look similar, except that I'm looping over sorted seated players. And for each one of these, I want to determine who should they be passing to, what color should they be passing to, and then I want to give their hand to that player. I'm going to first establish this local variable target and just set it to nil, which is Lou is just kind of nothing value. Local, because we only care about this variable within the context of this loop. And target is going to be who should this player, so the first time through it'll be white, who should they be passing to, which is going to be the next person in our sorted seated players. And this is where index is going to become important, because for most of the players, it's just the index plus one, right? White should pass to red, red should pass to orange, or you know, which ones are actually seated. But it gets tricky when you get to the end here and it's pink, because if we do pink plus 1, we're actually going to get an error in Lua because we're going to go outside the bounds of the list. So we need to know that if we're at the last one in the list, we actually want to go back to the first one in the list. So that's what our index is going to allow us to determine. So what we're going to say is if index is less than, and anytime we want to get the length of a list, we just use the little pound sign here, number sign, of sorted seeded players. So if the index is less than, let's say, we had a 5-player game, or in this case, because we're in debug, it's going to be all 8 of them. If it's less than 8, that means we're one of these first 7. In that case, we just want to do index plus 1, right? So we're going to set target equal to sorted seeded players index plus 1. So we're just going to get what's the next person. And remember, if we didn't have a full table of people, like if we didn't have orange, red would plus 1 would go to yellow because we've already filtered out orange when we built up sorted seeded players. So that handles that case, but the other case, which is going to be covered by else, meaning otherwise, if it wasn't less than sorted seeded players, that means that it was the final one. It was equal to 8 in this case. Then we want to set target equal to sorted seeded players 0. Or, sorry, 1. In Lua, things index from 1. In almost every other programming language, things index from 0. So you just I gotta constantly remind myself of that. So, going through this loop, we, and the first time through we're on white. We've now determined who white should pass to. In this case, it would be, red. Now we want to actually pass the cards to red. So let's do that by getting the player everything in their hand. So I'm going to just have another local variable here that I'm going to call player hand. And we're going to get the player using player of the current color, which would be white here. And there's a function for a player called getHandObjects, which is going to get everything that's currently in that hand zone, which technically you can throw like components in there or anything besides cards. So to do our due diligence here, we're actually going to loop over those, like every item in the hand. So I pairs of player hand. And we're just going to make sure it's a card. I mean, it's a little thing, but it's good to be thinking of these kind of edge cases of like, is it possible that they might have other things that they don't want to pass? And it's a good example here. So if we say if item, which at this point is going to be any object that was in their hand, if the tag on that, which is something that all objects have, if it's equal to card, which will be true for all cards, then that means that's something we would like to pass. And so the way we're going to pass it is objects have a deal method, similar to if you like right click, you can go to deal to a player. Which deal just means put this in some player's hand. And so we're going to do deal 1, meaning just like if this was a deck, it would be how many are you dealing? In this case, it's a single card anyway, so it doesn't really matter. We want to deal it to target, right? Because target is what we determined is the player that we want to deal to. Which in this case is just a string or just text of the color. But that's what this is expecting. Deal is expecting you to give the string of a color representing a player at the table. So that'll go here. It'll deal all the cards, from white to red. And then it's going to get to here, which is going to kick back to the beginning of our loop. Now, index is going to be 2, and we're going to be to red. And it's going to go through, and it's going to check, okay, who should red be passing to? It's going to get that, grab the objects in his hand, and then pass them. Now, once it's all done with that and it's passed everything around the table, it's going to set pass in progress back to false so our button can get clicked again, and it's going to return. Now let's try this and see what happens. And to be able to test this, I'm going to throw cards in everybody's hand. Oops. Actually, there's probably a way better way to do this by dealing to all. Okay. So everybody has cards here, and we want to see what happens when I click this. Okay, that was close, right? Like we saw cards pass around the table, but you notice this player has 2 cards and I have no cards over here. And this is what I was talking about earlier of the weirdness of all of that executing at once. Just runs into kind of some bugs and issues. And you can see if I keep doing it, like it kind of keeps doing weird things until I think finally, yeah, there's just 4 players that have 2 cards and then those just get passed around. Obviously, that's not desirable. So the way we are going to fix that is we're going to come back to our nice coroutine that we planned for. And we're going to, at the end of each one of these loops, so each time that we have a player pass the cards, we're just going to wait a single frame before we have the next one pass the card. Which I think it's just making sure the card is out of the hand before it does everything so that it doesn't accidentally pass something that's already been passed this round. So the way we do that is we call coroutine.yield, and in this case, we just say 0, which is the base way of saying just pause until the next frame. It's like the least amount we could pause. And so if we save and play with that and try this again, and actually I need to deal to everybody because I didn't, that isn't saved in the actual mod setup. If I do pass cards, you'll see that it works properly. There's a little bit of lag because my computer's working so hard to run this in my screen recording software simultaneously. But it actually shows you a little bit what that coroutine pause is doing. Like there's kind of this asynchronous factor to it of them getting passed around the table, which if nothing else looks cool. It's more like passing around a real table. But this works. We can keep doing this and keep throwing our cards around the table. And it would, be a lot more snappy if I wasn't running so much on my laptop right now. Now that's great, but you might be thinking, a lot of these cards that have drafting have something where, in the second round, we're now going to pass counterclockwise instead of clockwise. How would you then maybe have 2 buttons that you can pass in either direction? Well, let's think this through. If we go back into our code here, most of this logic would stay the same if we were going counterclockwise. We would still want to get, the order of people, and we would still want to do it. But the big difference is when we're determining who should the person pass to, instead of adding 1 to the index, we would want to subtract 1 to go the other way, right? Now, we could copy this entire thing and have another function and have that triggered by button and make that one change and it would work. However, it's not a great approach because you're going to get all this code that's the same in 2 places. And anytime you see that, that's kind of a red flag because duplicate code means that if you ever need to make any changes, it needs to change in more than one place, which it's much better to have it defined once where you can change it and it changes it for everything. So how can we reuse this as much as possible but get our functionality for clockwise? Or counterclockwise. That's going to be our goal, but let's start actually by adding a second button. So I'm going to grab this here, and I'm going to paste. And we're going to now change one of these to be pass cards clockwise, and we're going to have the other one be counterclockwise. I'm going to change the position of this one to be down so that it's below the other one. And we'll change the text as well to match what we want to say. So now if we go back into our Lua script, we need to change our pass cards function to be pass cards clockwise. But this is where things get a little tricky with Lua and with subroutines. So most functions you could have a parameters or arguments that you pass to the function. So we could have something here called clockwise, and when we call it, we could say, pass cards coroutine true if we want it to be clockwise and false if we don't. However, when you see how we call the coroutine here, there's no way to pass arguments to the coroutine. It's just a limitation of coroutines themselves, which is a little bit of a pain. But the way I'm going to get around that here is I'm actually going to wrap my coroutine in another function. So I'm actually going to say function, and for lack of a better term, we're going to call it pass cards wrapper. And this is my one that I'm going to allow it to pass a variable here. So this is something that when I call it, I can pass it a value which it'll put in clockwise, and then that'll be available in my function. If I was in a nicer code editor than the bare bones one in Tabletop Simulator, I would indent this entire section in here. But that's not easy to do in here. So I am not going to. But basically, this would all be indented, and this function is actually now defined within this other function. And it's only going to be called within that context. So now this is going to look a little bit different. We're going to change this now. Instead of calling the start Lua subroutine, we're going to call pass cards wrapper. And we're going to say true, because in this case, we are passing clockwise. Now this is going to get pulled out. And when we get into pass cards wrapper, the first thing it's going to do is define this function. So it's going to define this, but not call it yet. And then once that's defined, what I'm going to want to do is call it. So that's where I'm going to put my start Lua coroutine. So basically the same thing is happening here. It's ultimately going in here and calling the start coroutine on this coroutine that I've defined. The only difference now is I'm passing this value in, which will be put in clockwise, and now that's available in this entire function, including my coroutine. So I can use that in my logic to determine how it should act one way or another without having to duplicate a bunch of code. So where do we want the change to be made? And actually, before we get too far, maybe we should test that this is still working, because we kind of refactored how this is all working, but we should expect at this point that it still works for clockwise. So let's save and play. Let's deal everybody a card, and let's see if it still works. And it looks like it did. So we at least didn't break anything, and it would have been better to know now if we broke anything before I add more. But pass cards counterclockwise currently does nothing because we haven't defined that function. So what we want to do is in here, I mentioned that this is really the difference in logic, is we just want to pick a different target going to the right or the left depending on it's clockwise or not. So what I'm going to do is I'm going to add an if clockwise, because that's going to be either true or false. Then we want to do everything we did here, and I'll go through the pain of indenting these one at a time. And so that should still function just like it did before, because we pass in clockwise as true up here, and then it should go in here and run. But now we want to have the other case, if clockwise is false, we want it to behave differently. So it's going to look very similar to this. Man, sometimes my copy and paste in here, I'll blame Tabletop Simulator. It seems to happen disproportionately in Tabletop Simulator versus other programs. Okay, so we're copying this in here. And instead of adding one, we want to subtract one. But let's think through the logic here. We want to subtract one for every case except if it's the first one, right? Because if we're going backwards, it's the first one that's going to go out of bounds. So we now want to say if index, oops, I'm in the wrong one here. If index is greater than 1, because we're in Lua and the first index is 1. So if it's any number greater than 1, then we're safe to subtract 1. So we're going to set the target just equal to index minus 1. Otherwise, meaning it is that first one, which is white in our case, we want it to be the last one in the list. And the way we're going to do that is we're going to just set the index to the number of sorted seeded players. And if you're familiar with any other programming language, you would be used to going -1 to make sure that you're not going out of bounds. But because of how Lua does its indices, the last one actually is the same as the length. So in this case, it would be 8. It would get us our last one. So white would pass to, I think it's pink in this case. And that should be the only change, right? Everything else stays the same. It's just if it's clockwise, we want to pick the targets going clockwise, and if not, we want to pick the targets going counterclockwise. So the one piece I'm missing here is that we haven't defined our pass cards counterclockwise function. But that should be easy now. It should just be very similar to our pass cards clockwise. So let's put this here and change the name. And here it's still, if we don't want to do it if a pass is currently in progress, but the difference here is we want, when we call our little wrapper method, we want to set it to false so that it passes counterclockwise. So that should be everything we need. So let's see if this works. I'm going to save and play. I'm going to come here. I'm going to deal to all players and see if we can pass clockwise. Beautiful. What about counterclockwise? And look at that. Oh, wait, Houston, we have a problem. We're getting doubles again, which is actually interesting. All right, so it wouldn't be a complete Ludo Lodge scripting tutorial without me having an impromptu error that I need to work through. And so the reason this isn't working, and this is something I obviously didn't catch when I was playing with this beforehand, is because when we're passing in the opposite direction, I'm still going through passing them in the clockwise ordering, because I'm going through in sorted seated players, which sorted seated players is still in clockwise order. And because of that, it's not getting that nice pattern of pass and then this person pass before the card gets to them and this person pass before the card gets to them. Instead, it's pass and then it comes all the way around the table and the last person passes the card right back to white and white ends up with 2 cards. So off the top of my head, one different approach that we could use here is simply have a second table here called all players reversed. As far as I can tell, there isn't like a really nice method that some languages have to just quickly reverse the table. So I'm just going to do it manually. I may find that there's a better way to do this, in which case I'll probably update the code samples that I have online. But for purposes of right now, this should work. Fingers crossed. So I'm just going to have this reversed version of our table. And really, now the difference when we get into this function, if it's clockwise, we just want to use our normal list. And if it's counterclockwise, we want to use our other one. And that's going to completely get rid of this, logic of if clockwise on how we do the indices. Because now, if the list is reversed, it can still go to the next one in the list. And that should all work properly. So let me get these back here. And so at the beginning here, we're actually going to just set, we basically here when it does all players, we want to make sure we're using the proper one. And so I'm going to say player order, actually let's say if clockwise, then player order equal to all players. Else, player order equal to all players reversed. And then instead of using this here, we're going to use our player order. And so if it's clockwise, we're going to use the normal one. Otherwise, we're going to switch to the reversed one. Everything else will be the same. It's just that it'll have switched the ordering, which is used by everything else in this script. This is completely untested at this point. This is just me problem solving on the fly. So let's see what are the chances. Unfinished string near white. That just looks like I didn't write my table properly. And yeah, it's very descriptive. I didn't finish the string white. I just forgot my quote on white. Sometimes errors can be very descriptive. Loading complete. Let's deal everybody a card. Make sure we didn't break passing clockwise. Looks like it's okay. And look at that. It passes counterclockwise. It's beautiful. Not how I thought I was going to get to it, but it works. And that's everything I've got here. Hopefully that made some sense. Maybe it was helpful to see how I worked through some of that as I went. And maybe it's something that you could use in your projects, or maybe it's just a good example of getting more familiar with some of the things that can come up in coding. We talked about coroutines, which is something that hadn't come up yet before. If you enjoyed the video, consider giving it a like, subscribing to the channel. I appreciate you sticking around in the video this long, and I will see you in the next one.